Hello, my dear students. I welcome all of you to this lecture of subject NMOT, in which I am going to discuss the numerical method or numerical solution to the ordinary differential equations. In the very first and second semester, you have studied to determine the analytic solution of the ordinary differential equations of the first order. Now, we are going to study to determine numerically, of course, the solution of given ordinary differential equation. In general, the ordinary differential equation is given by dy by dx is equal to f of xy. So if dy by dx, for example, dy by dx is equal to say x plus y, this is ordinary differential equations. But if we are given only this ordinary differential equation dy by dx is equal to x plus y, then it is quite impossible to determine the numerical solution to this differential equations unless and until we know the initial condition or say boundary condition. So if dy by dx is equal to xy subject to initial condition, what is initial condition say? Y of x0 is say y0. What does it mean? Y of x0 is y0 means when initially value of x is x0, at that value of x equal to x0, y takes value as y0. So initial point is say x0 comma y0. Note this. And this is an initial point. It is also called as an initial condition. If these two numerical points they are given to us, then we can determine y of any x. If x is equal to say x0 plus h, then we can determine the numerical value of ordinate y when x is equal to x0 plus h. So we can say that x0 plus h as x1 and this y of x1 as denoted by y1. So the problem of finding the value of ordinate y at x is equal to x0 plus h is called as the initial value problem, numerical problem, of course. So in this topic, numerical solution to ordinary differential equations, we are going to study three different methods. One is Taylor series method, another is Euler's method, and the third is Runge-Kutta method. Runge-Kutta methods, of course. In this Runge-Kutta methods, we are going to study two different methods. Runge-Kutta method of second order and Runge-Kutta method of the fourth order. So at the outset, we shall study the Taylor series method. So what is Taylor series method? Taylor series method. I am going to mention the Taylor series method first, and after that we shall solve the numerical based on that method. So, method is, what is the initial value problem? Initial value problem is dy by dx. This derivative is also denoted by y prime is equal to, say, f of xy, subject to the initial condition y of x0 is equal to y0, and to determine y of x1. What is x1? x1 nothing but x0 plus h. Let us denote this y of x1 equal to y of x0 plus h by y1. Now I am going to employ the Taylor series. What is the Taylor series? Expanding. Y of x0 plus h, or say y of x1 in ascending powers of h. What is the Taylor series for y of x0 plus h? We also denote this as y of x1 in the ascending powers of h. The formula goes like this: y of x0 plus h times y prime of x0 plus h square by 2 factorial y double prime of x0 plus h cube by 3 factorial y3 prime of x0, and so on. That is how we have learned the Taylor series in M1 and M2. Maclaurin series, Taylor series, and all that. Let us denote y of x0 for sake of simplicity and understanding. Y of x0 as y0 plus h times y prime of x0 as y0 prime plus h square by 2 factorial y double prime of x0 by y0 double dash plus h cube by 3 factorial y0 3 dash plus and so on. What is this? This is the value of y. Sorry, y1. So y1 is equal to y0 plus hy0 dash plus h square by 2 y0 double dash plus h cube by 3 y0 3 dash plus h raised to power 4 by 4 factorial y0 4, and so on. This is equation 1. To find the value of y at x0 plus h. Similarly, y2. y2 is equal to x0 plus 2h. y2 is equal to y1, sorry, not y0, y1 plus h into y1 dash plus h square by 2 factorial y1 double dash plus h cube by 3 factorial y1 3 dash plus h raised to power 4 by 4 factorial y1 fourth derivative and so on. This is second equation. It gives me the value of y2 at x is equal to x2. This is value of y at x equal to x1. This gives me value of y at x is equal to x2. x2 is x0 plus 2h. In general, yn plus 1 yn plus 1 would be equal to yn plus h yn dash plus h square by 2 factorial yn double dash plus h cube by 3 factorial yn 3 dash and so on. This is the general formula for obtaining the successive values of y when x is equal to x1 x0 plus h, when s is equal to x2 x0 plus 2h and so on. Let me call this as A. So note down these three formulae, 1, 2 and this is general formula. So using this formulae, we shall solve one numerical based on this. So note down this. Okay students, let us evaluate this example. This is initial value problem. Why it is initial value problem? Because the initial condition y of 1 is 0, that is given to us, subject to the given differential equation. What is the differential equation? The derivative dy by dx of y with respect to x is equal to x plus y, x coordinate plus y coordinate. Okay. What do we want to do here? We want to determine value of y when x is equal to 1.1 and when x is equal to 1.2. What is given to us? Initial value of x is 1. So here what is x0? x0 is initial point. Initial value of x, given value, it is 1. What is y0? y0 is 0. Value of y when x is 1, it is. So initial point is 1 comma 0. What do we want? We want value of y when x is 1.1 and when x is 1.2. So we shall call this 1.1 as x1 and 1.2 as x2. So let me plot the solution. We know that. What we know? The Taylor series formula. x0 plus h. What is x0? x0 is 1. We want to determine at x equal to 1.1. So h would be 0.1. So y of 1.1. So here h is equal to 0.1. Formula we know, y0 plus h into y0 dash plus h square by 2 factorial y0 double dash plus h cube by 3 factorial y0 3 dash plus h raised to power 4 by 4 factorial y0 fourth derivative plus and so on. This is the Taylor series formula. It gives us the numerical value, approximate of course, value of y at x equal to 1.1. So we shall have to calculate, y0 is given to us. So we shall have to calculate y0 dash, y0 double dash, y0 3 dash, y0 4 dash, y0 5 dash subsequently. Question is how to determine this derivatives at y0. Okay. What is y0? y0 is 0. y0 is 0. What is y dash? dy by dx means y dash from the given differential equation. dy by dx is y dash. Y dash is equal to x plus y. First derivative. Y dash is equal to x plus y. Therefore, what would be equal to y0 dash? Y dash is equal to x plus y. So y0 dash would be equal to x0 plus y0. Initial points. x0 is equal to 1. y0 is 0. So y0 dash is 1. Now we want y0 double dash. Now differentiate this. What is y double dash? Derivative of y dash with respect to x. Derivative of x is 1. Derivative of y is denoted by y dash. So y0 double dash is equal to 1 plus y0 dash. So y0 double dash is 1 plus y0 dash is 1. So it is 2. Now, what is y3 dash? Third derivative. Derivative of this. Derivative of 1 is 0. Derivative of y dash is y double dash. So y0 3 dash is equal to y0 double dash. And y0 double dash is 2. Similarly, y4 0 dash would be equal to y3 0 dash. y3 and 0 dash is 2. And so on. So I have determined these 4 or 5 derivatives. I shall substitute this in equations A. Substituting in equation A, y of 1.1 is equal to y0. y0 is 0 plus h is 0.1. y0 dash is 1 plus h square by 2 factorial y0 double dash, it is 2 plus h cube by 3 factorial y0 3 dash is 2 plus to power 4 by 4 factorial. Y4, Y04 dash plus and so on. We shall have to add this infinitely term. But it is approximately equal to, I shall add this 1, 2, 3, 4 and 5 terms only. So it is 0.1 plus 0 plus 0.1, 0.1 square by 2 plus 0.1 cube by 3 0.1 raised to power 4 by 12 up to this term. And numerical answer for this is 0.110 approximately 0.110333847. So that is the value of y when x is equal to 1.1. Earlier when x was 1, the value of y was 0. So it has been increased by 0.110333847. So that is the first value of y when x is equal to x1. Let me call this as y1. Now it remains to determine the value of value of y when x is equal to 1.2. So note down this. Now value of y when x is equal to 1.2. We call it as y2. I have given you the formula. It is equal to y1 plus h y1 prime plus h square by 2 factorial y1 double prime plus h cube by 3 factorial y1 3 dash plus and so on. Question is, y1 is we have obtained just now. Y1 is 0.110333847. Question is how to determine y1 dash. Y dash is given to us. Y dash is x plus y. So y1 dash is equal to x1 plus y1. What was x1? x1 is 1.1. What was y1? y1 was 0.110333847. So y1 not double dash, but it is single dash. y1 dash. So it is equal to 1.210333847. That is the value of y1 dash. What is y1 double dash? Y double dash is 1 plus y dash. So y1 double dash must be equal to 1 plus y1 dash. That is equal to 1 plus y1 dash we just determine as 1.210333847. So it is 2.210333847. y1 3 dash is equal to y1 double dash, and that is equal to 2.210. 2.210333847. y1 3 dash is equal to y1 double dash. So y1 4 dash is equal to y1 3 dash. Differentiating this successively. So 2.210333847. Similarly, y fifth derivative, sixth derivative. all these values will be equal to 2.21033,847. I shall substitute these values here. That is equal to. So y1 is, where is y1? 0.11033,847 plus h into y1 dash. H is 0.1. y1 dash is 1.21033,847 plus h square by 2 factorial. I'm sorry, this is h is 0.1. H square by 2 factorial into y1 double dash. y1 double dash is 2.210 33,847 plus h cube by 3 factorial y13 dash is 2.21033,847 plus h raised to power 4 by 4 factorial to 2.21033,847. If I add this finite number of terms, this is approximately equal to the value comes out as 0.24280 160. This is y2. x2 is 1.2. y2 is again using this value. You can determine y3 when x is 1.3, y4 when x is 1.4. Successively using this or approximating the Taylor series formula. I have added only 5 terms. 1, 2, 3, 4 and 5. So that is how we determine numerically the value of y for a given x. So that illustrates our topic of the Taylor series method for finding out the numerical solution to the initial value problem. Thank you very much. If you have any doubt, any queries, koi shak, you can always open up your doubts to me at any time, 24/7. Thank you very much. Thank you.